We are working on area of triangles. Area of triangles, this is all about triangles. And in the past, you may have remembered area equaling 1/2 base times height. Does that look familiar? Okay. There was another one too that you may have learned in your geometry days, and area is equal to the side squared times the square root of 3 over 4, and this formula is for equilateral triangles. Do any of you remember this one? Has that been some? It depends on who you had as a geometry teacher, whether or not they expose you to that one. But those are all very nice. This is an equilateral triangle. This is side, because all the sides are the same, so it's the side squared times the square root of 3 over 4. The other one is for any triangle, 1/2 the base times the height. The problem is there are occasions where we're not given the base and the height, and it's not an equilateral triangle, and therefore we need another formula, and that's where the trig comes into play. So we talked a little bit about side, angle, side, 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 angle yesterday. So when we have a side, angle, side scenario, that means I am given two sides and an angle that falls in between. So I'm given two sides and an angle that falls in between. If I label this triangle A, B, and C, that means I have side A, I have side B, and I have angle C. My area formula is 1/2 times A times B times the sine of angle C. And they use K for area when we get into trig. It's another thing that I'm not 100% sure why, and I should have at this point probably looked it up, but I never have. But K is what we use for our area. So if I'm given side, angle, side, and again, if I label my triangle as so, I have A, I have B, I have angle C, I can just plug them all together into that formula. Now remember, it's not about the letters on the sides as much as it is about the location. And so there are variations of this. If I'm given side B and side C, then I need to know angle A. And if I'm given side A and side C, then I need to know angle B. Those are all the same formulas. It really is not necessary for me to probably write it out over and over and over again, because again, it's not about the letters of the things, it's about where they are. And this is the formula I'll use if I know two sides and the angle that falls between them. I'm not always given two sides and an angle that falls between, so other times I will be given either an angle side angle or an angle angle side, and that looks like this. Here is angle side angle. An angle, a side, and another angle. That's angle side angle. Or I would be given an angle, another angle, and a side that's not between them. Those letters are telling. They tell us the order that things are given. This means that the side has to fall in between the two angles. This one means that the two angles do not include the side that falls. So the side is outside of it, okay? Not between the two angles. Regardless, if I have A and I have B and I have C, I have A, I have B, and I have C. In this case, in both the cases actually, side C is the side that I know. My formula looks like this. It is the side I know squared times the sine of the other angles, not the one across from it, divided by 2 times the sine of the third angle, or the angle that is across from the angle that I'm given. So regardless of which situation you're given, you have to find the third angle. So must find third angle. Have to, or you will not be able to do this particular formula. Again, it is not about the letters, it's more about the position. So our other variations of this, the key point is, if B is the side I know, then the sine of B has to be on the bottom. Or better than that, whatever side I know, the angle that it's across from has to be on the bottom. The letters are going to change. And then the rest are going to be sine A, sine C, and the 2 will also be always part of that. This particular area formula poses the most problems because of the fact that it's got all of those signs in there, and we always have to remember to close our parentheses, and we also have a product in the denominator, so we also have to remember to put a parentheses around that. When we do a problem like that, I'll go through that with you. But our last variation of this is, if I know A, then the side across from A, or the angle across from A, has to be in the denominator, and I fill it in with the other 2. Don't forget the 2. Before I move on to the next one, I do want to, again, really point this out. You need to put the denominator in parentheses when you're plugging this in, the whole denominator. And you also need to close the parentheses around your top. So I like to make those stand out. That's why I put it in a little bit different color, although on the blue it's hard to tell that's a different color. But make sure that you do close those parentheses. It's not part of the formula, but if you forget to do that, you're not going to get the right answer. It's not going to put it in the right order. Okay? All right, our next one is a side, side, side. That means I'm given 3 sides. And again, A, B, and C. I know side A, I know side B, I know side C. And this formula uses something called the semi-perimeter. And that's exactly what it sounds like. The semi-perimeter is half of the perimeter. Semi-perimeter. That's S equals A plus B plus C divided by 2. Make sure that you put that whole sum in parentheses before you do your division. A plus B plus C divided by 2. And that is going to go in the area formula. There is only one variation of this because it uses all 3 sides and no angles, so it doesn't matter which side goes where. Again, it's not about the letters, it's about the fact that we have 3 sides. And this one is the square root of the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. That is that area formula. Again, there's only one variation of it. It is known as Heron's formula or Hero's formula because Heron is a mathematician that sort of perfected this. And then they did a shortcut of Hero's formula for it. So you may in a future class hear that come into play. But that's my area formula for that. Again, this guy is a troublemaker. Again, that is the only one that does not give us unique information. And so if I'm given this ASS, A, B, and C, that means I am given 2 sides, and a non-included angle. And the only way that I can find an area for this is find another angle and use one of the other formulas. So all across the board, it just makes us work harder. The total ASS, okay? Okay. So that's all we can do with that one. We just have to find some different information. Usually I find another angle. I'll find whatever angle I'm able to find. So in this case, I'd be able to find B. And then I find A, and I use the first one. Or you can find A and use the second one. It really doesn't matter. But here we go. Again, this goes pretty quickly once we're doing this. Most people think this is the most simple section of all. We draw our triangle. We figure out which formula we want to use. So I'm going to draw my triangle. This is S, T, R. I know that R is 15. I know that T is 10. I know that S is 61. I have to decide what information I'm given and where I go from there. This is a side angle side. So I'll go up to my formulas, I'll pick the side angle side formula, and I go ahead and plug it in. My area is 1/2 times one side times the other side times the sine of the angle. And it's just really plug it in your calculator. I didn't put any measures on here, so we don't know what the lengths of our T and R and S are. So it is area. I'm going to put units squared on there. If you have feet, it'll be feet squared. Miles, it'll be miles squared. Did you get the same thing I did? Yeah. Okay, good. All right. How do you feel so far? Not too bad? Okay, questions? Anybody? No? Okay. So I'll draw my picture. This is triangle KHP, and I know that side P is 9, side H is 9, side K is 5.7. What kind of triangle is this? Isosceles, nice job. But these formulas don't differentiate between isosceles or acute or scalene or any of those kinds of things. We just have to take the information that we're given and pick the appropriate formula. Clearly this one is a side, side, side. Great. And so that means I have to find the semi-perimeter. So my semi-perimeter is 9 plus 9 plus 5.7 divided by 2. Again, please make sure you put that top in parentheses if you're plugging it in your calculator, or just hit equals before you divide. And I got 11.85. And then I can plug it in my area formula. 11.85 times 11.85 minus 9 times 11.85 minus the other 9 times 11.85 minus the 5.7. When you're plugging this in your calculator, it is important that you put parentheses around those subtractions. You can't just like plug it in. Again, your calculator will do the order of operations, and so it will do all of the multiplication parts first and then do the subtraction second, and we want it to do all the subtractions first and then do the multiplications. So again, when you plug it in, please make sure that you do your parentheses around it. And that's how I finished off mine. It doesn't matter, especially for these. Like I'm showing kind of a lot of work. I don't care if you jump from this step to this step down here. It really is important, though, to me that you at least write what you plugged in your calculator. And the reason for that is sometimes you write it correctly, but you enter it wrong, and at least you can get some partial credit for it. If you just give an answer and it's wrong, you lose all your points. So keep that in mind. All right, so let's do a couple more. I don't think we need to do all these, do you? No. So let's do a couple more. It looks like I've got either an angle side or a angle side angle here, so I'll know once I draw my picture. This is H, P, K. H is 20. P is 139. And side K is 9 in the S. That is an angle side angle. Again, remember, it doesn't matter if it's an angle side angle or if it is an angle side. You always have to find the third angle. And so I have to find this missing angle here by using that 180 minus 139 minus 20. Is that 21? So 21 is my missing angle. And then when I do my setup, make sure that the side and the angle that are opposite each other are the furthest apart in the equation. Just like the law of cosines where you had to have it furthest apart, same thing goes on here. So my 9 and my 21, when I do my setup, the sine of the angle has to go down on the bottom, and the 9 squared will go up on the top. I don't want to forget the 2. I don't want to forget my parentheses. And then I want to put in the other two angles. So the sine of 20 and the sine of 139. Not necessarily in any order. That part doesn't matter. But this one is going to be, again, the biggest troublemaker in terms of entering it properly.
Why is it the 2 sides?
Why is it the 2 sign? In the formula, it always has the 2. You could do the same thing by doing like half of 9 squared or 0.5 times 9 squared if you wanted to, but the 2 will always be in there because that's the 1/2 part of the whole area formula. $25.4-ish. Anybody get that? Yeah, okay.
I keep getting like 3.3.
Did you make sure you put parentheses around the whole bottom? That's a super huge key. And you have to make sure that you close the parentheses around. Better? Okay. Everybody all right with this? Anybody else having any issues? Again, it boils down to this parenthesis around the bottom. That's the big thing. Just on a side note, you could also enter this as, is that readable? 0.5 times 9 squared times the sine of 20 times the sine of 139 all over the sine of 21. You could enter it that way and get the same thing. That takes that 2 out of the denominator, and then you don't have to be as picky about putting parentheses around the denominator, but you still do have to close off your signs here. Okay, and that's all about the half, 1/2 the base times the height. That's all that 2 is in there, the same part of any other area for a triangle. Okay? All right. I just want to set up the next one and then solve number 5, and then we're going to call it done. Okay? So I'm just going to set up the next one. So on the next one, I'm going to draw my picture, and that's Z, X, Y. And angle Z is 141, and angle X is 20, and side Z is 12, and I need to find my third angle, so 180 minus 141 minus 20, and then that gives me 60, 19, okay? What I wanted to, or what I was trying to say on the last one, and what I want to point out on this one was an angle side scenario. It's all about position where you put things. The 141 and the 12 are the side and the angle that are across from each other. So when I set this up, the 12 squared will go on the top, the sine of 141 will go on the bottom, or you will not get the right answer. That particular layout is necessary. And then the 2 and the parentheses and the other 2 angles, not necessarily in any order. And again, you can go through and figure that out and solve it if you want to, but that's the layout of that particular problem. That is super important about position. All right, and then we're going to go to our last one, and that one is our RST, and we get angle 113, we get side R, which is 10.1, we get side T, which is 4, and this is the side angle, or the angle side. And again, it is one of those things that is causing trouble. And so, because of this, we have to do more work. And so I'm going to start by trying to find another angle. And the only angle I have enough information to find is angle T. So the sine of 113 over 10.1 is equal to the sine of T over 4. And now I'll go through and I'll solve that. Are we getting pretty smooth with the law of sines, plugging it in? Yeah, it's not too tough. So I got the sine of T to be 0.36455, blah, 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 blah. There's more. And I'll do the sine inverse. Oops, oops, oops. No, I won't. Oh my God, I don't know what's happening here. I'm having issues. It's not doing what I want it to do. Did anybody get an angle T? 21.4. Okay. All right. Super. Yeah. Yeah, yep, and it did something weird. So I don't know what that is on this one. I'll have to look into it. Yeah, it might just be a hit twice or something. Oh, it is. You hit it twice. Okay, yeah. Okay, so I'm going to go ahead and find angle T, or I did already. Then I'm going to go ahead and find angle S, 180 minus 113 minus 21.4, and that'll give me that angle there. and I got 45.6. Now, the reason that I always like to find the third angle is because then I find the angle that is between the two sides I know, and I can use that first formula. I have to find it anyways if I'm going to use the other one, but this one sets me up really nice for that first formula, so I'll go back to K equals 1/2 times 4 times 10.1 times the sine of 45.6. When we do problems like these, depending on where you round and when you round, things are going to have a little bit of wiggle room. When you get into calculus, they're real particular about making sure you round to 3 or 4 decimal places all the time so that everybody is consistent. For the accuracy, if you get into machining, they always have to go to the 10,000s if you don't have anything in the shop classes. So with our little bit of wiggle room, our answers might vary slightly, okay? What did we get for K here? 14 point, and then that's my unit squared, okay? So that's what you're all about today. Tomorrow, depending on whatever, weather and everything, is word problems and review. And then Monday is your test. Now, the word problems aren't so bad. It's really just drawing the triangle and putting places on. So they aren't too terrible. Honestly. Come on.